Now, since we have defined reduction and oxidation, we have defined the process of reduction and the process of oxidation, and we are making mention of oxidation number. You see, for example, we have talked of what? Of oxidation state, that we are saying that we have been explaining that the oxidation number increases, the oxidation number reduces. So it is good for us to define what oxidation number is. It is good for us to define what oxidation number is, and who can define oxidation number, and we will be able to say that now when you look at an atom in a compound, you see that that atom in a compound has a number of electrons it can gain, or the number of electrons it can lose to return to its neutral state. For example, you see like oxygen. For example, like you see like let's say oxygen. Oxygen can gain 2 electrons to return to its neutral state in a compound. In most cases, you see, in most cases in a compound, it can gain 2 electrons to return to its neutral state. So you see that the oxidation number, or the oxidation state of oxygen, will be -2. So we can be able to define oxidation number as the number of electrons. Oxidation number is the number of electrons an atom in a compound, a compound, number of electrons an atom in a compound can gain or lose to return to its neutral state, because you want to go back to its original state. The number of electrons an atom in a compound can gain, the number of electrons an atom in a compound can gain or lose to return to its neutral state. And now we have been talking of actually reduction and oxidation. Reduction is the gain of electrons or an electron, while oxidation is the loss of electrons or an electron. So it will be good for us to define what a reducing agent is. So it will be good for us to define what a reducing agent is. A reducing agent and the oxidizing agent. We have a reducing agent and an oxidizing agent. Oxidizing agent. Now you see that a reducing agent is a species that loses electrons in a redox reaction. It is a species that loses electrons in a redox reaction. Now, for example, when we say a reducing agent, it means it is an agent that causes, or it is a species that causes another species to be reduced. And for that species to let another species to be reduced, it have to lose its electrons. So that when that species that is going to be reduced gains the electrons, its oxidation number, it reduces. And then when you look at it, you see that at the end of the day, that species which is a reducing agent, it finally ends up being oxidized. Bear in mind that a reducing agent in the process ends up being oxidized, because when the reducing agent loses electrons to reduce the other agent, what happens? When it loses the electrons, its number of protons are more greater than the number of electrons, and so its oxidation number increases. And the other species oxidation number reduces. So we can be able to define a reducing agent as a species that loses electrons. A species that loses electrons in a redox reaction. A species that loses electrons in a redox reaction. Full stop. We see that this species ends up being oxidized in the process, and we see that this species ends up being oxidized in the process. Now we can also define now a an oxidizing agent. It will be the opposite for a reducing agent. So an oxidizing agent is a species that gains electrons in a redox reaction. So we see that this species ends up being reduced in the process. So we see that this species ends up being reduced in the process. So this species ends up being reduced in the process. You can have examples of reducing agents. We can have agents like metals, e.g. sodium, potassium, because they always have that great tendency to lose electrons. And for example, we have oxidizing agents like oxygen, non-metals, halogens. They have that great tendency of gaining electrons. So you see, those are cases of reducing and the oxidizing agent. You see, we have some other oxidizing agents like dichromate, permanganate. So those are all oxidizing agents. Now we have make mention of all the